Today we're reviewing how to solve systems of equations. So we have two methods that we're going to use. The first one is elimination. So let's take a look at that. So when I'm solving a system of equations using elimination, what that means is that I'm getting rid of one of the variables out of both equations. So I want to eliminate one of the variables. So our main goal in solving systems of equations is to end up with a pair of coordinates that we can plot on a grid and find out where these two lines intersect. So each of these equations represents a line. So if I want to find out where these two lines intersect or where they cross, then I need to solve for x, and I also need to solve for y. So I need a value for both. So in the end, I want to end up with a pair of coordinates. So I want an x and a y. So when I'm solving using elimination, I'm going to get rid of one of the variables. So the first one that I notice is that the y's both have the same coefficient. So I want one that has, so eliminate with the same coefficient. So I want the same coefficient, so they both have a coefficient of 1. And opposite signs. So in order to get rid of it, they have to have opposite signs, so a positive and a negative. So we see here with the x, I have different coefficients, so different numbers in front of the variable, and I have the same exact sign. So I'm not going to be able to actually eliminate that or get rid of it. So let's start by eliminating the y. So we're adding down, so everything is added down. And so I have negative 5x and a negative 2x. So that's going to give me a negative 7x equals, because these ones are going to go away, and then negative 29 plus a negative 20, which is going to give me a negative 49. So from here I'm just left with a simple one-step equation. So I'm going to divide both sides by negative 7. So these negative 7's reduce to 1, so leave me with just a 1x equals, and then negative 49 divided by negative 7 is going to give me a positive 7. So my x equals 7. So I'm going to take this x and I'm going to plug it in to my coordinate pair. So my x. So now I need to find y. So in order to find y, I'm going to choose one of these equations. Doesn't matter which one. Let's do the second one. So I'm going to rewrite that as negative 2. And then whenever I see the x, I'm going to plug in my 7. So you can have your x there in this equation. I'm just rewriting it. So I plug in my 7. So minus y equals negative 20. So again, I just took this second equation. So I had negative 2x minus y equals negative 20. And I replaced this x with my 7. So now I have negative 14 minus y equals negative 20. And I continue solving for y. So in order to do that, I have to add 14 to both sides. So when I add 14 to both sides, these two go away, leaving me with just negative y on this side equals negative 20 plus 14, so negative 6. And now I can't keep a negative y, so I have to actually divide both sides by the negative. So if we think about it, we're dividing by a negative 1 on both sides. So the negatives now go away. So this was a negative 1 divided by negative 1. So those go away. Leave me with just y equals negative 6 divided by a negative 1 gives me a positive 6. And so this y value is now going to go up into our coordinate pairs. So our y value up here. So my solution to the system of equations is my coordinate pair. So this is where the two lines are going to intersect. So where they're going to cross. All right, and so that is solving using elimination. So next thing we're going to take a look at is solving actually using substitution. So when I'm substituting, much like how I'm substituting in a value for one of my variables, I'm going to be substituting in this entire algebraic expression, so this entire thing, in for y. So what that looks like is I'm going to rewrite this. Let's rewrite it over here. So I have 2x equals negative 1. And if I'm going to substitute this entire thing in for my y, I have to do minus 3x minus 11. So I substitute in all that for y. So all of this comes over in here for y. Now from here, I see I have a negative, so I need to distribute the negative in order to solve this. So let's rewrite that on this next line. So 2x equals negative 1, and then negative times a positive is going to give me a negative 3x, and then a negative times a negative is going to give me a positive 11. Now I want to continue by combining like terms. So combine like terms. So what I see is that on the right side of this equation, I have a negative 1 and a positive 11. These are my two that are going to be like terms. So I'm going to rewrite this down here. So I'm 2x, and then I'm going to subtract a negative 1 from 11. So I've got negative 3x plus 10. So combining these two gives me the 10. So when I combine those two, I get my 10. Now my next step is to actually get all the x's on one side and keep anything without an x on the other. So in order to do that, I see I have a negative 3x. So a negative 3x. So in order to get the 10 or the negative 3x to this side, I have to add 3x to both sides. So I'm going to add 3x to both sides. So this negative 3x and the positive 3x go away, leaving me on this side with a 5x. And then on the right side, a 10. And then from here, I just continue to get x by itself. So I divide both sides by 5. This goes to 1. Leave me with x equals 2. So now I know that x equals 2. So if we remember, we're looking for a coordinate pair. So I need an x and a y. So x and a y. So I'm going to put in my 2 over here that I found for x. So this 2 can now be plugged into one of these equations. I'm going to choose this first one. It seems like it'd be a little bit simpler. So y equals 3x minus 11. So if I plug in this 2 for my x, I'm going to be able to find out what y is. So y equals 3 times 2 minus 11. Then I just continue to combine everything until I get a value for y. So I have 3 times 2 gives me 6 minus 11. So y equals negative 5. So now that I know my value for y is negative 5, I can then take that and plug it in over here to show my final answer for my final coordinate pair. So my x is 2, my y is negative 5, and that is the solution to my system of equations using substitution.